we're going to just start by seeing what you know. So with indices, we're talking about things with powers. So we're just going to start by filling these in. Let's just see what you can do and what you can't do, and then we'll go from there. So here, question 1, it says state the missing index. So the index is the power. Okay. This is page 2, yes. So I've lost my pen. Hang on a minute. Thing doesn't want to connect today. So what goes in the box? So it says 5 to the power of what makes 25? 5 to the power of 2. Good. So you just pop that in while I fix this up. Okay. So 5 to the power of 2 is 25. Stick a little 2 in there. Then the next one, 2 to the power of what makes 8? 3. So what that means is 2 times 2 times 2. So 2 multiplied by itself 3 times makes 8. So 2 times 2 is 4, and then times that by 2, that's 8. This one here, negative 2 to the power of what makes negative 8? So negative 3. So what that means is negative 2 times negative 2 times negative 2. Okay? Which makes it. So negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Okay. Then this next one here, negative 4 to the power of what makes 16? Just 2. Yeah. So then it's negative 4 times negative 4. So negative times negative is positive, and then 4 times 4 is 16. So that's positive 16. Okay. So just a review of what that is, what indices are. State the number or pronumeral that is the base in these expressions. So the base is the big number. Okay, so yeah, first one's 3. What about B? Negative 7. Make sure you include the negative. What about for C? 2/3. Good. So 2/3 is your base. Everything is 2/3 to the power of 4. And then Y is your fourth one, is your base. So it can be letters as well. All right, so then number 3, state the number that's the index. So the indice, the high little number in the expression. So the first one, 4 to the power of 3, the index is 3. Negative 3 to the power of 7, so the index is just 7. Okay, so it's just that little number at the top. Okay. C, what's the index in that? 4. Okay, so it's to the power of 4. What is xy to the power of in D? 13. Okay, so that's the index. I might leave number 4 and I'll come back to that. Okay, let's just firstly, what's a prime number? Let's actually go through that.
Numbers that can only be divided by themselves and 1.
Yeah, so they can only be divided by 2 numbers, themselves and 1. So for example, a prime number is 2. Okay, 2. Then we've got 3, because 3 it's only 3 times 1. Then we've got 5, 7. Why is 6 not a prime number? 1. You got 1 and 6 and 2 and 3. So there's more than just the number itself and 1. So it's not a prime number. Okay. I'm going to do an example to show you what prime factors are from this. So let's just work out what prime numbers are too. I should have made that the question. All right. So then underneath, let's keep going. So the recap. So 5 times 5 times 5, I can also write as that too. Well, no, that's not the answer. 5 to the power of 3. Okay. That's how I want you to think of. If you work it out though, if you evaluate it, 5 times 5 is 25. 25 times 5, 125. Okay. Now A, we've got how many A's here? 1, 2, 3, 4. So this is A to the power of 4. Okay. So this first bit is what we call expanded form. Okay, because it's written out completely what it means. And then this part with the index here is index form because there's an indice involved. So the bottom number provides the number that you're multiplying it by. The index tells you how many times it's multiplied by itself by. So you could say 5 to the power of 3, it's 5 multiplied by itself 3 times. 5 times 5 times 5 times 5. I said that too many times. 5 times 5 times 5. 3 times. Okay. So, so let's fill in these gaps. So we say indices, which is the name of our topic. That's the plural of the word index. So the little number at the top can be used to represent a product of the same factor. Then we say the base is the factor in the product. So the bottom number is the number that you're multiplying by. The index, or the other names that you might see, the exponent, or we can say more commonly the power. We say 5 to the power of 3. Okay, so that's the index, is the number of times the factor is written. Okay, so there's another example on your right there. We've got 2 times 2 times 2 times 2 times 2. So we could say that that's 2, that's the factor, to the power of 5, because we're multiplying it by itself 5 times. Okay? And then we could do the same with algebra, with letters, x, 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 times x times x times x times x. And this is where I harp on about doing curvy x's when you're doing algebra, and so that when you do times, when you write something like that, it actually makes sense. So get in the habit, if you're not already doing it, of writing curvy x's when you're doing algebra. Because if you need to do a times sign, it makes it really obvious what the difference is. And if your x's do not have curves, make some curves. I won't be able to read your maths, that's the problem. And you'll get confused too. It's more for yourselves. So even if you're one of those people that writes x's like that, and then you make the time sign smaller, it's still x. So it's still times. Make it curvy. All right, a to the power of 1 is like saying a. So it's like saying, if I say something 5 to the power of 1, it's just the number itself. So what happens is, if I write any number, so say I write 12, okay, that's like saying 12 to the power of 1. If I have, there's a page number 2 here, 2, just the number 2 by itself, that's like saying 2 to the power of 1. So if there's no number there, it means that it's to the power of 1. Okay? All right, cool, over the page. Now, this is working out prime factors. So what we can also do, and this is kind of going back to year 7, I don't know how much you remember, probably nothing of year 7, but basically we can write a number as a product of its prime factors. So you can actually, every number can break down into prime numbers. So I've got one example here, 108. So what we do is we can work out, we go, okay, what's 2 factors of 108? 2 times 54 makes 108. 2 is a prime number. Okay. Then I can break 54 down into some factors. 2 times 27 makes 54. 2 is a prime factor. Keep going. So 27, 9 times 3 makes 27. 3 is a prime factor. And then 9, 3 times 3 is 9. They're both prime factors. So we do these factor trees so we can work out what the prime factors are. So then the way we can write this, we can say 108 is equal to 2 times 2 times 3 times 3 times 3. So if we multiply all those prime factors together, makes 108. Okay? And you can put it in a calculator if you want proof that makes 108. Now, we can then write that with using the index form as well. We've got 2 times 2, so we could write that as 2 to the power of 2, and then that would become 3. What to the power of? 3 to the power of 3. So I can actually rewrite 108 in terms of prime factors in expanded form or in index form as well. Yes?
Is that as far as you can go with
Yeah. Once you hit prime numbers, that's it. Then we go into fractions. You don't want to go there. Yeah. Okay. So we can express every number that exists in terms of prime factors. Okay. So some examples. So we'll do more of those. So we want to write example 1 says write in expanded form. So basically this is a to the power of 3. So you just write it out. A times A times A. So just make sure you've got it written out the number of times the index is. Next one, xy to the power of 4. So because it's in a bracket, it means that everything inside is multiplied 4 times. So you can, I just like to write it out. X times y, that's the first time, times x times y the second time, times x times y the third time, times x times y the fourth time. Okay?
I curved my X.
It's beautiful. Excellent. Okay. The third one, we've got 2a to the power of 3, b to the power of 4. Treat each one individually. So that 2, if there's no power there, what's the power? What did I say? 1. So it's 2 to the power of 1. So we just start with writing a 2 times. Then we look at the next one, a to the power of 3. So there's 3 of them. 1, a times a times a. And then look at the b. So b to the power of 4. So we've got 4 b's. 1. Oh, my b's look like 6's too. I've got to make them look more straight. 3 times 4. Yeah, my b's look like 6's. I curve them too much. Make them straighter. Okay? So that's how we write them in expanded form. Any questions about the first one? Yep.
You know how you did X times Y times X times Y?
Yep.
Could you put XY times XY times XY?
Yes. So with this second one, you could do xy times xy times xy times xy. Yes, that's possible. You could also go x times x times x times x times x 4 times, y times y times y times y. Well, I mean, it doesn't matter. I just write it all out like that. The way I did it's the easiest way. Yeah. Okay. There's less ambiguity if you write it out that way. Okay, number 2. Now it says write each of the following in expanded form and then evaluate. So if you see the word evaluate, it means work out the number. Okay, so the first one, 5 to the power of 3. So 5 times 5 times 5. So we've written it in expanded form. Then evaluate means work it out. 5 times 5 is 25. 25 times 5, 125. Okay. All right, so the next few, I've just kind of done them on purpose for a reason, but we get to still do the same thing. So negative 2 to the power of 3, negative 2 times negative 2 times negative 2. So writing it out in expanded form. Then working it out, negative 2 times negative 2 is positive 4. Positive 4 times negative 2, negative 8. Okay. Next one. You guys can keep going if you're happy with this. Negative 2 times negative 2, 4 times. Negative 2 times negative 2. That makes negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2, positive 16. Yeah. Okay. Next one, negative 2 to the power of 5. So we'll do that 5 times. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. So I could even do, if I want to do a shortcut, I've got 16, right? Times negative 2, negative 32. Okay. And then 6 times, so we'll just write it out 6 times. Negative 2 times negative 2 times negative. Yeah. You're seeing a pattern? Yeah, good. That's the point of me doing this so many times. 2, 4, 6. Negative 2 times negative 32 times negative 2 makes 64.
Look for the pairs. You can make like even number of pairs.
Yeah.
And there's one left over.
Yeah. So the trick is with this kind of thing, if you see, and this has to be, the negative has to be inside the bracket for this to work. The negative is outside, different set of rules, okay? So if the negative is on the inside of the bracket and your indice is an even number, your answer is always going to be positive. It's just a little trick, okay? If the negative number is on the inside and your index is odd, then you're always going to end up with an odd number, with a negative answer. It's just one of those little like tricks that you can use as a shortcut instead of trying to work it out every time.
Is this the same thing general word last term?
Probably. Yeah, they would have done indices. Yeah.
Are they going to do
We take it to.
equations?
Sorry, what?
Are they going to do?
Yeah, they do. Yep. Yep. They will. Okay. So F, I just want to show you how to set this one out as well. So this is 2/5 to the power of 3. So we go 2 over 5 times 2 over 5 times 2 over 5, like so. Okay. And then, so we want to work that out. 2 times 2 is 4. 4 times 2 is 8. And then 5 to the power of 3. 5 times 5 is 25. 125. Okay. So I've written it out and then I've evaluated it. Oh yeah, I've done that. What do you notice about examples B to E? So yeah, that's just a trick. If you see negative to the power of an odd number, it's going to be a negative answer. So negative number to an odd power equals negative answer. Negative answer? Answer? Okay. And then negative number. So negative number to an even power is positive answer. But this has to be inside brackets, yeah? Inside bracket. Okay. Yeah. But if you don't remember, it doesn't matter. But it just might be a quick, good trick for you. Okay. Next. Oh, sorry. I'll leave that there. We going okay?
No. Like the first one's inside bracket.
Yeah, the whole thing. So that number has to be inside the bracket for this trick to work. Okay. For both. You don't have to. If you don't remember it, you don't remember it. But it's just a good trick. Might save you some time on a test or in class. Okay. All right, next one. Example 3. Good. All right, so example 3, we ready? Yep. Write each of the following in index form. So going the other way this time. We've only got 1 6, so we'll just write the 6. How many x's do we have? 4. So 6x to the power of 4. Then this one, we've got 2 3/7, so 3 over 7 to the power of 2. And make sure your bracket covers the whole fraction. And then times 4/5 to the power of 3. Okay. It doesn't say evaluate, it just says write the following in index form. Then C. Let's see, we've got 8 to the power of 2. How many A's have we got? 3. A to the power of 3. B to the power of 3. Yeah. That is all. Okay. So, last one. Express 48 as a product of its prime factors in index form. Lots of ways to do this one. So I thought I'll just show you a couple. Well, there's more. There's like literally at least 5 or 6 ways to do this one. So start by writing 48. What are 2 factors of 48? 2 and 24? Okay. You could do 6 and 8 if you want. 2 and 24. So that's a prime factor, so you just stop there with 2. 24, what are some factors of 24? 12 and 2. I'm just, yeah. I can use your numbers in another one. 12 and 2, that's a prime factor. Stop there. What are some factors of 12? 2 and 6, okay?
No, it's 3 and 4.
Yeah, it doesn't matter. And then 2 and 3. So then we can say 48 to write it as prime factors. 1, 2, 3. These are our prime factors here. Oops. There. You don't have to circle them. I'll just circle them to make them obvious. 2 to the power of 4 times 3. And if you really like, I can show you another version because some people might like to work their numbers out differently. So I could do like 48, 6 and 8. So I heard someone say that before. 6 8's 48. So then I can look at 6 first. So that's 2 times 3. So they're prime factors. So I can stop there. 8, we've got, 4 times 2. So 2 and 4. And then 4 I can break down again into 2 times 2. And you see you get the same answer. So it doesn't matter which way you do it. I just do 2s because then you just like looks nice.
It looks really pretty.
Looks prettier. But
I like
but sometimes you do need to split it into 2 and you just have to accept it.
prettiness comes first.
Yeah. And if it's even, just do 2s. It's because your 2's gonna be one of them.
Is there a way to figure that out without having to draw the 3? Like,
Is it one the shortcut?
I've seen people. So the other way I've seen people do it is they go like this. How do they do it? They go like this, and then they write the prime factor. So 2 is a prime factor, becomes 24. Like because 2 times 24 is 48. Then they write another prime factor down. 2 times 24 is 12. Another prime factor, 6 divided by 2, 3, and that's your last prime factor. That's another way to do it.
there's no
I like the tree though.
Yeah, there is no formula though.
There's no formula. You just have to
I like the
draw it out or draw it vertically.
I like it.
Okay, that's enough of me talking.